In September 2022, NASA shook the world with a stunning new image from their super telescope. This jaw-dropping photo of Neptune, our most detailed glimpse in 30 years, has reignited curiosity about the icy, mysterious giant at the edge of our solar system. But what makes Neptune so enigmatic? Before we dive into the fascinating secrets of this blue ice giant, take a moment to hit that subscribe button and ring the notification bell so you never miss out on our latest videos. And if you find this deep dive into Neptune's mysteries intriguing, give us a thumbs up. Now, let's uncover the truth about Neptune, the planet that has puzzled scientists for decades. Neptune is the 8th planet from the Sun, and since Pluto's reclassification in 2006, it's now the outermost planet in our solar system. Measuring by diameter, Neptune ranks as the 4th largest, the 3rd most massive, and the densest planet in the solar system. With a mass approximately 17 times that of Earth, it's slightly more massive than its twin, Uranus. Composed primarily of gases, liquids, and ice, Neptune is classified as an ice giant. It orbits the Sun at a distance of 2.8 billion miles, taking an incredible 164.8 Earth years to complete a single orbit. Neptune holds a unique place in history as the first planet discovered through mathematical predictions. While Galileo Galilei observed the blue planet in the 17th century, he mistakenly identified it as a star. It wasn't until 1846 that British mathematician John Couch Adams and French astronomer Urbain Le Verrier independently calculated the existence of Neptune based on irregularities in Uranus's orbit. Shortly after, German astronomer Johann Gottfried Galle confirmed the planet's presence through direct observation from the Berlin Observatory. Neptune's signature blue color is due to the unique vibrational patterns of methane in its atmosphere. This distinctive hue inspired its name after the Roman god of the sea. Despite its prominence, Neptune remains one of the least studied planets. Observations over recent decades have revealed dramatic changes in its atmosphere, raising concerns among scientists who struggle to interpret these findings due to the limited data available. The first detailed images of Neptune were captured by the Voyager spacecraft in 1989. Launched in 1977, Voyager took 12 years to reach Neptune. Interestingly, Neptune wasn't the primary destination of the mission. The dual Voyager probes were designed to explore the entire solar system and then venture into interstellar space. The images taken by Voyager in 1989 remained the best we had of Neptune for over 30 years, marking a significant milestone in our understanding of this distant, icy giant. The first Hubble Space Telescope also provided images of the ice giant, but the quality was rather mediocre. Scientists were all the more excited for the launch of the new James Webb Telescope. In September 2022, we saw Neptune in a completely new way. The James Webb Space Telescope captured the clearest view of Neptune's rings in over 30 years, revealing the ice giant in an entirely new light. Using the NIRCam near-infrared camera, which images objects in the 0.6 to 5 micron range, Neptune appears not as a familiar blue planet, but as a very dark object. This darkness is likely due to methane gas, which strongly absorbs red and infrared light. Bright stripes and spots in the image are clouds of methane ice that appear almost white due to sunlight reflection. This imaging technique made Neptune's fine ring system clearly visible for the first time. While the rings have been known to scientists for a long time, earlier technologies struggled to capture them due to their faintness, likely caused by their composition of ice crystals. A thin, bright line around Neptune's equator suggests the violent atmospheric circulations, such as winds and storms, on the planet's surface. The image also clearly shows a previously known vortex at the South Pole and, for the first time, a continuous band of clouds enveloping the planet at higher latitudes. Light filtering methods allow scientists to determine the exact composition of gases and other structures on Neptune from afar. Studying the rings, first observed by Voyager 2 in 1989, will yield new insights into this distant ice giant. For astronomers, this marks a significant milestone in Neptune research, and serves as a much-needed advancement in the absence of a dedicated Neptune probe from NASA. The processes on Neptune's surface remain some of the last great mysteries of our solar system. In 1989, Voyager 2 discovered the Great Dark Spot in Neptune's southern hemisphere, a massive whirlwind similar to Jupiter's Great Red Spot. However, when researchers using the Hubble Space Telescope studied this area in 1994, they were astonished to find that the Great Dark Spot had vanished. In its place, a new dark spot had appeared in the northern hemisphere, only to disappear a few years later. This rapid change revealed that Neptune's enormous storms are far more short-lived than those on Jupiter, where the Great Red Spot has been raging in the same location for centuries. Despite their fleeting nature, Neptune's storms are incredibly intense, with wind speeds reaching up to 1,305 miles per hour, making Neptune the undisputed champion of wind speeds in our solar system. By comparison, the most violent tropical cyclones on Earth reach around 186 miles per hour. Encountering a Neptune storm would be an unimaginably extreme experience. In 2020, scientists were baffled when a team of researchers from the University of California, Berkeley, observed a storm on Neptune that was wider than the Earth's Atlantic Ocean. The storm, located in the northern hemisphere, had been under observation since its discovery in 2018. In 2019, the storm began drifting southward toward Neptune's equator, where such storms typically dissipate. However, in August 2020, Hubble revealed that the vortex had unexpectedly changed direction, heading back north, an atmospheric behavior never before seen on Neptune. While Hubble has tracked similar dark spots for nearly 30 years, this movement was unprecedented, leaving researchers puzzled. The largest storm ever observed by Hubble on Neptune measured 4,600 miles in diameter. Since 1993, scientists have noted that these storms seem to disappear, possibly dissipating, only to reappear nearby. One theory suggests that these storms may only disappear superficially, continuing to rage in Neptune's deeper layers and occasionally resurfacing. However, what exactly happens in Neptune's depths remains unknown. To uncover these mysteries, a probe would need to be sent to Neptune, similar to the Cassini mission to Saturn. Such a probe could potentially descend through Neptune's layers, collecting crucial data. While this idea is currently just a possibility, it's likely that Neptune will eventually receive its own dedicated mission. There is even speculation that NASA might combine a mission to Neptune with the search for the elusive planet X, which is believed to orbit beyond Neptune. Orbital calculations of some distant objects in the solar system suggest the possible existence of another large planet beyond Neptune. This hypothetical planet, often referred to as Planet 9 or Planet X, could be orbiting the Sun in a highly eccentric path, so far away that it remains invisible due to poor lighting conditions. If Planet X is indeed this distant, its orbital period around the Sun could be as long as 1,000 years. This would mean that the planet might only become visible to modern telescopes once every few hundred years, making its detection a rare and challenging event.